I'm going to explain a strategy design pattern in C Sharp. First, let's read this particular sentence. The strategy design pattern allows choosing which algorithm to run from a family of algorithms. So that is actually the purpose of a strategy design pattern. In order to explain this, I use a C# code. Actually, this is just an example. So by looking at this C# code, you have to understand the idea of the design pattern, and then you should be able to apply the concept in your own problem. Okay, then let's look at the code. Okay, so now here we have a class called C. The name of the class is C. There we have a field. It is a public field. Public, and the name of the field is value, and data type is int. Then this one. Okay, now we have a field with name value in class C. Now we have another field. Name of the field actually now this one we have not specified the access modifier. In C# by default the access modifier of fields in a class is private. Therefore this is S, the type is IS. Okay, this is actually an interface. IS is an interface. So later I will discuss that. If you look at the methods in the class, we have public method. Its return type is int. Okay, then we have another method called switch, that is also a public method. Its return type is void. Those are the two methods available in class C. Okay, now here we have two classes. First let's look at class S1. We have a class called S1. Inside the class we have a method called M. Okay, its access modifier is public. Class is M, and it has a parameter C of type C. Okay, parameter name is C. its type is capital C. Okay, C means the type is of this class. Now its return type is int an integer. This is our class S1. Now we have another class called S2. The name of the class is S2. It also has a method with name M, and the access modifier is public. Then here also we have a parameter C, and its type is capital C, and its return type is int. Now actually if we look at the sentence we have read at the beginning, this one, the strategy design pattern allows choosing which algorithm to run from a family of algorithms. In this example, I have used two algorithms. Actually, you might feel these are not algorithms, okay, but very small two algorithms I have used. One algorithm is included inside this method, okay, M, and the other algorithm is included in this method, okay. So now again go back, let's go back to our classes. Here what we do is, in the algorithm, this is actually the algorithm available in class S1. This is the algorithm. C dot value. Now here C, the simple C, actually it if you consider simple C, actually it can it stores memory location of an object of type C, okay. This type C, in this way it refers, it can store the memory location of an object of type C. Here it should be capital C, an object from C class, okay. So here we pass memory location of such an object to here. Now we know that here we have two fields, therefore this will contain some value for the value field, okay. Then S field also can take another value, okay. Our object is, I have just put question marks here, it may contain some value, here it may contain some value. In order to mention that, I have simply put question marks. That is not an standard notation, okay, just to mention that here it contains a particular value and here it contains a particular value. Okay, then what we do, here we access inside class S1 we have included, inside class S1 inside method M we have included one particular algorithm. The algorithm, what algorithm does is it adds three to this value. Okay, that this is the algorithm, one particular algorithm, that this is available in our M method of class S1. Okay, now if you look at class S2, there we include another algorithm. What is done by that is C dot value minus 5. This is the other algorithm, C dot value. It reduces 5 from the value field of our object. This is our algorithm 1, this is our algorithm 2, algorithm 1 and algorithm 2. Now we have two algorithms. We need a, here we have the dot operator. I'm not sure it is visible in the video. So okay, now we have two algorithms. Okay, let's algorithm 1, algorithm 2. Then we actually in this strategy design pattern, we have a way to switch between these two algorithms. Okay, so that is the idea. This is just an example in order to understand the idea behind strategy design pattern. Okay, now let's see now. Now hope you understood this one, and here the then before that, in order to do that, now the two algorithms we have included inside two classes, and method signatures are similar. Okay, so now we can create an interface of type IS. There we now we can include the signature and from this particular interface we realize from this interface we realize S1, from this interface we realize S2, and now you can understand this one. The type of S field is IS, that means this particular interface. And now if you go back to our class C, now you can see sorry, the method A. This is a method, that a public method that returns an integer. Now this one returns s dot m. Okay, s dot m. Now s s field refers actually here. Yes, if you go to here, you can see what we do. Inside this class, we may do something like this. We create an object from S1 class. S1 class, an object from S1 class. Okay, then that memory location of this object is stored in S variable. Okay, S variable. Okay, that's what we do. Then here inside this method s.m, we access the method m available in our object. M method here, now this is our class. So in this object we have a method called m. Then to m we pass, we use the this keyword. Okay, this keyword is used. This means now the same object. Once you have created an object from class C, there we have a field called s. S.m we access, and to C we pass the same C object. Okay, and then the value we return from method day. Now you have, I hope you have a rough idea about method operation A. Okay, so still you do not understand the complete logic. You are getting some rough idea about it. Okay, that's enough. Then once I have finished explaining the complete code, then you definitely will understand the complete logic. Then let's look at the switch method. There what we do, the condition we check S is S1. That means S is S1. S is S1 means from this one, what we do is S can refer now. This is the type of S is IS. Okay, this interface. Therefore, S variable can store memory location of an object of type S1 or memory location of an object of type S2. S is S1 means S stores memory location of an object of type S1. Okay, in that case we have to create an object from S2 class, and then its memory location should be stored in S. Okay, that means S value should be replaced from an object of type S2. Otherwise that means S is S2, no? If we are going to in main method, we are going to assign to the S field either memory location of an object of type S1 or memory location of an object of type S2. Then else means therefore S is S2. That means S stores memory location of an object of type S2. Okay, in that case, what we have to do is we create an object from class S1 and its memory location is stored in S variable. That means the value of S is replaced by the memory location of an object of type class S1. Okay, that is the simple idea about this code. Then I remove the highlighted parts. Now let's look at the main method. Okay, then inside once I explain the main method, you will understand it completely. Okay, still you have a rough idea, just a rough idea about the pattern. So first now we have a class called program. Okay, this is the class called program. Inside this class we have included the main method, therefore this is called the driver class. This is called the driver class. This is the class which drives our program. Okay, so now the execution of our program begins from the very first line of code, this one. There what we do is we create an object from class C, and memory location of that object is stored in reference variable T. Okay, so let's see now. We go here, an object of type class C is created. Now when we create the object here, we have set a value to this value field. Now when we create an object, initially its value field will take the value of 7. Okay, because here we have assigned 7 in the class. That means when we create an object from class C, its value field initially will take the value 7. Okay, now we then a variable of type S is there. Then here what happens is an object of type S1 is created. An object of type an object of type S1 is created. So its memory location is stored in S field. Okay, now here in this object we have two operations. I have not written them, method A, operation A and operation switch. Okay, then after that, now we have this one, memory location of this particular object is stored in T variable. Okay, now we move to the next line of code. We invoke T dot switch operation with respect to this particular object. Okay, so now let's move to that. Then it checks the condition. If S is S1, S is S1, okay, this is either true or false. Now in this situation, S stores an object of type S1, therefore this condition is true. This condition is true. Okay, this condition is true. Therefore an object from S2 class will be created. This condition is true, therefore an object from S2 class will be created. Okay, then what happens? The memory location of newly created object. Memory location of newly created object will be assigned to S field of this object. Okay. So now this link is no longer there. Okay. Now S stores the memory location of this particular object. Now if you look at this object, the memory location of this object is not saved in anywhere. Okay, then what happens? This object will be deleted from memory by C# compiler. Therefore, for simplicity, I erase this one. Okay. Then we move to the next line of code, console.writeLine T. We invoke T dot A, method operation A of this object we invoke. Then let's see. In class C you have A. When we invoke that, it returns S dot M. S dot M means the M method inside this object. M method, now we have to move to class S2. Now this is the method. There M method, now we pass S dot M, we pass this. This means here actually the same object C. This stores the memory location of this particular object. Okay, memory location of this particular object we pass to the method M of this object. Okay, that is why S dot M. Then in method M of our S2 object, the class is S2, therefore M method inside class S2. Now we pass, now C, here C variable, simple C variable refers this object. Okay, because here we pass this, that means memory location of this object. Therefore simple C variable here now stores the memory location of this object. Therefore, here c dot value means 7. Okay, now let's see. C dot value 7 minus 5 will be assigned to C dot value. C dot value means now C dot value means this particular field. C dot value, this particular field, we access the C dot value. Okay, this is our C dot value. The value is 7, we reduce 5, now new value is 2. 2 will be assigned to C dot value. Here instead of 7 now we have 2. Okay, we have 2. Now this method returns 2. Okay, this method returns 2. This one was our, this is what we invoke t dot a. Now once we have invoked t dot a, then we had to return s dot m. T dot a means the method operation a inside this object. There we access s dot m, operation m inside this particular object. It now return the value 2. Okay, it returned the value 2. Therefore this one displays the value 2. Okay, value 2 is displayed. Then after that we move to the next line of code, t dot switch. Then we invoke t dot switch. Invoke t dot switch. T dot switch, that means the switch method in this particular object. Okay, switch method in this particular object. Now let's go to our class C. So there we have the switch method, this one. So switch method, now it checks the condition S is S1, S is S1. This is the condition is checks. It checks then S is S1. The condition is false. Okay. The meaning of this one is S stores memory location of an object of type S1, but here S stores memory location of an object of type S2. Therefore condition is false. Condition is false. Okay, condition is false. Therefore this is not executed and else part will be executed. That means an object from S1 class will be created. S1 class will be created and its memory location will be assigned to the variable s. Okay, its memory location will be assigned to the variable s. Therefore, this link is no longer there. Now s stores the memory location of our newly created object. Now, if you consider this particular object, memory location of this object is not stored in any reference variable. Therefore, this will be deleted from the memory by C# compiler. Okay, so therefore I erase this one. Now actually when we invoke this particular, actually we invoked this particular line of code. Now then okay, we invoke this particular line of code. Then we move to the next line of code, t.a. t.a. Therefore, the a means a operation inside this object. This one, it returns s.m. S.m means the m operation inside this object, and we pass this. This means now the memory location of this object. Okay, memory location of this object. We pass it to m method in this object. Now let's see, the type is s1. Therefore, let's look at the class s1. Here now this C simple C now is stored in the memory location of this particular object. Therefore, C dot value means now 2. Okay, 2. C dot value is 2. We add 3. C dot value is 2. We add 3 and then assign it to C dot value. Now 5 will be assigned to value. This value will become 5. Okay. Then this returns 5. C dot value will be returned from here. That means inside a method we return 5. Okay. Therefore, this will return the value of 5. Okay, therefore the value of 5 is displayed, and therefore this is the output of the code. Then hope now you could understand the logic. Okay, and in here I have shown you the output 2 to 5. Okay, then hope you understood the logic of strategy design pattern. Now, as I have mentioned at the very beginning, this is just an example, for strategy design pattern. Now you should get an idea from this, and you should be able to apply the concept to your own problem. Okay, and hope you understood properly, and thank you for watching the video.